Hello there, and I'm going to teach you how to encrypt using an affine cipher. An affine cipher is an example of a substitution cipher. When encrypting using an affine cipher, a letter occurring in the plain text will be replaced by the ciphertext letter. For example, the plain text letter A might be replaced by the ciphertext N, but this is usually using a formula. So as you can see here is a table of the 20. We're going to work with the English alphabet because that's a common alphabet that everyone is familiar with. A to Z, 26 letters. So the plain text values don't actually go from 1 to 25, but actually from 0 to 25. You will see later on as to why. Each cipher letter is given by the formula E open bracket X close bracket is equal to AX plus B mod M. A and B are the key. This means you multiply the plain text value, which is X, by A, and then you plus B. That's how you find the key. M is the number of letters in the plain text. So for example, M in this case would be 26. So when we're going to be encoding words, we're going to always be working with mod 26 because there's 26 letters in the alphabet. A should always be relatively prime to M. This means A and M should have no common factors with each other, apart from 1. Hence why I've written greatest common divisor, AM is equal to 1. So typically A, i.e. the number, the coefficient of the X term in the formula should be a prime number, whether it's 1, 3, 5, 7, 11, so on, so forth. Let's move on to the first question. In code, it's cool using EX is equal to 5x plus 8 mod 26. So first, we're going to write out the words in the letters in each individual column. It's cool. Each row, so for the first row, this is the plain text letter. This is it. X is the plain text value. These numbers here. So for example, for the letter T, plain text value will be 19. For the letter M, plain text value will be 12. This is what you put in the X row. For the 5x plus 8, that is what you will get when you put in the X value into these equations. So for example, if X was equal to 1, 5x plus 8 would be 13. 5x plus 8 mod 26 is the remainder of when you put 26 into the number, when you divide it by 26 or any multiples of 26. If you want to know how to work out the modulus or find the remainder using the modulus, refer to my video, how using the modulus to find the remainder. You will understand how to find the remainder using mod, whatever the number it is for M. And C will be our ciphertext letter. But the values in the row above, we'll use these as plain text values to work out our ciphertext letters. So let's go to the first question. In code, it's cool. So I've written out the word in individual letters in each column. We're going to write down its plain text values. So So for I, its plain text value is 8. So we're going to put 8. For T, its plain text value is 19. So we're going to put 19. For S, 18. For C, it's 2. For O, it's 14. For O again, it's 14. For 11. For L, sorry, it's 11. So a way to work this out, because you might not be given this table, you might just do it in your head. So a way to work it out, because there's 26 letters in the alphabet, you simply, whatever letter you're working with, know what number it is in the alphabet and minus 1. So for example, H is the 8th letter in the alphabet, minus 1. That would be 7. Therefore, its plain text value will be 7. Same with O. O is the 15th letter in the alphabet, minus 1. Its plain text value will be 14. That's how it's worked out. So now we've got our X values. We can key it into our equation, 5x plus 8. So when x is equal to 8, 5x plus 8 is 48. When x is equal to 19, 5x plus 8 is equal to 103. When x is equal to 18, 5x plus 8 is equal to 98. When x is equal to 2, 5x plus 8 is equal to 18. When x is equal to 14, 5x plus 8 is equal to 78. When x is equal to 14, 5x plus 8 is equal to 78 again. When x is equal to 11, 5x plus 8 is equal to 63. So now we've got our values, and we're going to work out 5x plus 8, so i.e. these values, mod 26, the remainder of when how many 26s can go into that number, and what's the remainder afterwards. So 26 can only go into 48 once, therefore its remainder will be 22. For 103, 26 can go into 103 3 times, therefore its remainder will be 25, because it could go to 3 times, 78. 103 minus 78 will give you 25. That will be its remainder. Again, 26 will go into 98 3 times. 78. 98 minus 78 is 20. So that'll be its remainder. 26 is greater than 18. So 26 can't go into 18. So therefore, its remainder is just 18. For 78, because 78 is a multiple of 26, there's no remainder. Therefore, it's 0. Can you see why now the plain text is 0? The plain text value is 0. You'll see why. Again, repeat the process for 78. And then for 63, into how many 26s can go to that? 2 26s, 52. 63 minus 52 is 11. 11 again. L's lucky, isn't it? As you'll see. So therefore, we use these values as plain text values, and we're going to use it here to work out our ciphertext letters. So for 22, ciphertext it's letters W. Therefore, the ciphertext letter will be W for when it's I. For when T is the plain text, it's ciphertext, because the ciphertext value is 25, so its ciphertext will be Z. For S, it will be U. For C, it will be S. For 0, it will be A, and A again. Now can you see why the plain text value is 0 for A? Because let's say we numbered from A to Z 1 to 26. When there's a remainder of 0, what letter are you going to put down? This is why we put down 0 as the first plain text. So it's as the first plain text value for the first letter in whatever alphabet you're using. For 11, L. So yeah, that's why I said L's lucky, because L is encrypted using its formula is L again. And there's your answer. Therefore, It's called encrypted using the formula EX is equal to 5x plus 8 mod 26 is Wazal. However you pronounce that word, it's not, I don't think it's a real word. And that's its word encrypted. Let's move on to the next question. Encode freedom using E open bracket X close bracket is equal to 7x plus 3 mod 26. So let's first input all the individual letters of the word freedom. And then now we're going to put it plain text values. So for F, it'll be 5, because it's the 6th letter of the alphabet, it's -1. For R, 17, because it's 18th letter in the alphabet. For E, it's the 5th letter, -1. 4. For E again, 4. For D, it's the 4th letter, -1, it'll be 3. For 0, it'll be 14, because it's the 15th letter in the alphabet, -1. M is the 13th letter in the alphabet, it'll be -1, it'll be 12. So when we put the X values into the formula, 7x plus 3, when X is equal to 5, 7x plus 3 is equal to 38. When X is equal to 17, 7x plus 3 is equal to 122. When X is equal to 4, 7x plus 3 is equal to 31. Again, 31. When X is equal to 3, 7x plus 3 is equal to 24. When X is equal to 14, 7x plus 3 is equal to 101. When X is equal to 12, 7x plus 3 is equal to 87. And now we're going to find out the mod 26 of these values. So 26 goes into 38 once, so the remainder will be 12. 26 goes into 122 4 times, therefore the remainder will be 18. 26 goes into 31 once, therefore the remainder will be 5. Again, 5. Because 26 is greater than 24, there's no remainder because 26 can't go to 24, therefore remainder will be 24. 101, 26 can go into 101 3 times, because it's 26 multiplied by 3 is 78. 101 minus 78 is equal to 23. That's the remainder. Again, it can go, 26 can go to 87 3 times. 78, 87 minus 78, you have 9. So now we have our values to work out our ciphertext letters. So 12 in the alphabet will be M. 18 will be S. 5 will be F. 5 again will be F. 24 will be Y. 23 will be X. And 9 will be J. Therefore, the word freedom encrypted using the formula EX is equal to 7x plus 3 mod 26 is MSFFXYXJ. That's not a word, but that's it encrypted. With Affine ciphers, you can also use it to decipher, to decrypt words. So for example, you could decrypt this word to get the word freedom. But that could be a topic for another video. So this is how you encrypt a word using the Affine cipher. Thank you for listening, and goodbye.